Okay, everybody, take a look at Tuesday's page of the packet. We're talking about factored form of quadratics. But remember, before we're allowed to convert a quadratic equation into factored form, we have to start in standard form. So I want to take just a minute and talk about standard form for 1 sec. The standard form of a quadratic is y equals ax squared plus bx plus c. Let's go ahead and write that down. But in particular, what I want to pay attention to right now is a. In all of the examples we've done so far, when we're trying to factor, we've been using equations where the a equals 1. So we might have something like 1x squared plus 3x plus 2, for instance. But when there's a 1 in front of the x squared, we don't normally write it. So all of our equations have looked like this, with just an x squared in the front, and we have factored them. Those are what I would call easier problems to factor. They are straightforward. We can start them off all the same way. But not every quadratic equation starts with a 1x squared. We could have a 2x squared, or a 3x squared, or a 4x squared, etc. And if we ever have to factor those, things get a little more complicated. That's what we're going to work on today. So on the line below this, there's a blank that says some quadratic equations have an a value other than 1. And if our a value is not 1, it's going to change the way we factor. The process will be the same, but a lot of the logic we use is going to change a little bit. Plus, there might be some other things we can do to simplify our problems before we begin. So we're going to talk about those methods today. There really are only 2 different things we do in situations where our a value is not 1. Really only 2 things we do. And we'll talk about when we use those, in what types of problems, and how you can tell. We're going to do that just by exploring this through examples. So we're going to dive into example 1, and as we're doing example 1, I will explain the process and how it works. In example 1, we're looking at 2x squared plus 22x plus 48 equals 0. This is in standard form equals 0, so we're already good there. Now, since this has a 2x squared in the front, this is bound to be a pretty complicated factoring problem, unless we can simplify it before we get to that point. So the very first thing we're going to do in every single problem is try to divide by a. That is always going to be our step 1. If we have an a value in front of our x squared, we're going to try to divide by a. And here's what I mean by that. Whenever you're dealing with an equation, you are always allowed to manipulate the 2 sides of your equation. The rule is you have to do the same thing to both sides. That's the only rule. So I can divide everything on the left side by 2, as long as I also divide everything on the right side by 2. But what's on the right-hand side? A 0. So if I divide the right-hand side by 2, it's not going to change anything. It's just 0 divided by 2 is still 0. So this is basically a freebie. This is a free pass. I can just divide everything by 2. It will simplify the left, but it doesn't do anything really to the right-hand side. If I divide 2x squared by 2, I just get 1x squared because the 2's simplify. 2 divided by 2 is 1. So we end up with 1x squared. If I divide 22x by 2, I end up with 11x. That simplifies as well. And if I divide 48 by 2, I get 24. So my whole problem simplifies, And each of our various pieces still is a whole number, but it's a simpler whole number. It's smaller, easier to deal with. But the kicker, the part that we're really, really excited about here is that the 2x squared turned into an x squared. And we know how to factor this. This is easy for us to factor. We've been practicing this for over a week now. So let's do that. We want to convert this into factored form. So we're going to draw a generic rectangle. We're going to put the first term, x squared, in the top left, and we're going to put the last term, positive 24, in the bottom right. Then we need to start thinking about our factors. We know in order to have an x squared in the top left, both of our factors have to begin with x and x. Then we need to make a list of numbers that multiply together to give us 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Our number 24 is positive, which means that these two things we're multiplying together must also both be positive, or they could both be negative. So we need, since the signs are going to be the same, since it's either a plus plus or a minus minus, we're looking for a sum that gives us 11x. So look down the list, try to find two numbers whose sum is 11, and that should pretty quickly take us to the 3 and the 8. So we're going to have a 3, we're going to have an 8, and we have to decide between plus plus or minus minus. But since we want them to add together to give us a positive 11x, we're going to use the plus plus. So most of this problem was review. The only new step was dividing everything by 2. So step 2, which I didn't even have to tell you guys, was factor. So we're just adding this one new step at the beginning. Try to divide everything by whatever the a value is. All right, so take a moment to finish this problem out. We need to rewrite this in factored form. X plus 3, x plus 8 equals 0. And then you're going to end up with two different roots. I'm going to do this the long way. Since we have two factors that are multiplied together and they equal 0, we know that one of these, at least one of these, has to be 0. If it's the first factor that equals 0, then it's x plus 3 equals 0, which would give us the answer x equals negative 3. If it's the second factor that equals 0, x plus 8 that equals 0, we would solve this and get the root x equals negative 8. So those are our two answers. And you can shortcut this. You didn't have to write out that intermediate step. You know your roots are just going to be the opposite of the factors. All right, so let's take what we just talked about and try to apply it in example 2. I'm going to make a note to myself here on the side. Step 1 is try to divide by a. And in this example, what is a? Can I get a volunteer to tell me what a is equal to in this example? 3. Thank you, Kendall. A is 3. It's just the number that's right here in front of your x squared. So my step 1 is try to divide everything by a. So take a look up at the screen. If I divide both sides by a, my first term, 3 divided by 3, would just give me a 1 x squared. But my second term, 2x over 3, does that simplify? If I actually take 2 divided by 3, you either end up with a fraction, 2/3, or you end up with a decimal, 0.66666. When we're dealing with factoring problems, we never, ever want to get decimals or fractions. Ever. So please, if this doesn't divide and give you a whole number, don't do it. So that's why step 1 says try to divide by a. We will not always be able to divide by a. So sometimes you're just going to have to draw an X through this step. That did not work. It did not work. We want whole numbers so that we can factor. If you don't get whole numbers, it simply doesn't work. So instead, we have to move on to step 2, which is factor. Things are about to get different. Things are about to be a little bit more complicated. If I want to factor 3x squared minus 2x minus 5, I'm going to start with my generic rectangle just like usual. The first term always goes in the upper left corner. So my first term this time is going to be a 3x squared. We can already see how this is different from all of the other examples we've done so far. We've never had anything in that top left corner other than an x squared before, so this is new. The last term, negative 5, goes in the bottom right-hand corner. And now it's our job to start thinking about what our factors have to look like. So first, let's focus on these two parts of our factor, our two factors. We have to fill these blanks in with two things that multiply together to give us 3x squared, not x squared. Normally, we just do x, and then we're done. But this isn't as mindless. Here, we're going to have to think about it. Can I get a volunteer to tell me if they can think of anything that multiplies together to give us 3x squared? Any thoughts? So x times x isn't going to work because that just gives us x squared. But we need a 3x squared, so we're going to have to get a 3 in there somewhere. Does anybody have any ideas? Joel, what are you thinking? Perfect. Joel says 3x times 1x, and that is exactly what we need. So instead of writing it as 1x, I'm just going to write it as x, but it means the same thing. 3x times x gives us x squared. So we could use these two values. So now let's think about what that's going to do to the rest of our grid. In particular, I want you looking at this 3x. This 3x has already had an effect on this first box, but it's also going to affect the second box. Because whatever we put up here will have to get multiplied by the 3x in order to fill in this box here. So it's going to have an effect throughout the rest of our problem. So we'll pay close attention to that as we go into our next step. Our next step is make a list of numbers that multiply together to give us 5. It's a pretty short list, 1 times 5. Specifically, though, they need to multiply together to give us a negative 5. So one of them will have to be a plus and the other one will have to be a minus. Since our signs have to be different, what that tells me is that our numbers need to have a difference that's the same as this middle box. Well, our numbers are 1 and 5. Is the difference between 1 and 5 2? No. So what's going on here? That's where this 3x is going to change things. So let's say hypothetically, I take my 1 and my 5 and I'll put them here and here. We already said the difference between 1 and 5 is 4. But watch what happens as we fill in the internal boxes. The box on the top right will be a 15x because we have to multiply the 5 times the 3x. So we won't just get a 5x. We will get a 15x. Then in the bottom left-hand corner, we get a 1x, which we would have expected. But we don't get a difference of 4 here. We get a difference of 14 because we don't have 5 in 1, we have 15 in 1. So we're already starting to see how that 3x is affecting things. The problem is this isn't right. Even if it doesn't matter which one of these we make negative, we're never going to end up with a 2x or a negative 2x when we add those two blue terms together. So the 5 and the 1 are not working for us in the place where we've put them. In other examples we've done so far, it has not mattered which side you put it on, but here it's going to matter because whichever number you put in this position gets multiplied by the 3x. So if I switch the 5 and the 1, instead of multiplying 3 times 5, I'm going to be multiplying 3 times 1. So you get 3x and 5x. Does everybody see how that worked? There's not really a quick or cheat or formula way to do this. For the most part, we're just going to be trying something, seeing if it works, and if it doesn't work, trying something different. This is a bit of a process of trial and error. So we tried first putting the 5 on top and the 1 on the left, and that didn't work, so we switched them, and this looks like it's working. The difference between 5 and 3 is 2. Now we just need to make sure that we make the right one negative so that we end up with a negative 2x in the middle. So the 5x has to be negative. Whoa, give me a second. All right, so the 5x has to be negative and the 3x has to be positive, which makes our 5 negative and our 1 positive. Now we can write this in factored form. X plus 1 times 3x minus 5 equals 0. And we need to solve this for x. Now, most of the time when we do this, we're looking at simple things like x plus 1, and we know a really quick cheat to find our roots. We just flip the sign, and that's no different. But now that we have this other more complex factor involved, I'm going to write this out the long way just to see how this plays out. So if these two factors are multiplied together and they're equal to 0, what we know is that at least one of these factors has to be 0. One of them has to be. If it's the first factor that's equal to 0, then we would have x plus 1 equal to 0. Solving this is relatively straightforward. We just subtract 1 from both sides, and you get x is equal to negative 1. The second factor is a little more complex. If the second factor is the one that's equal to 0, we would have 3x minus 5 equals 0. And to solve for x, we would add 5 to both sides. And then we would divide both sides by 3. So we end up with two answers, negative 1 and positive 5/3. So I first want you to notice that the first answer we ended up with was exactly what we would have expected based on our factor. So we had our factor, x plus 1, you change the sign, you get the root minus 1, just like we would have predicted. The second one gave us an answer that looks a little strange. First of all, it's a fraction, but there is a pattern here. We ended up with positive 5 over 3. So think about it this way. Positive 5 over 3. We still switch the sign, so it's positive, not negative like our factor. But then we have to put it over 3 because of that 3 in front of the x. So there's a little bit of a pattern here that might help you find these roots faster. In example 3, we have another standard form quadratic equal to 0, and it has an a value that isn't 1. It has an a value of 5. So our first step is try to divide by 5. Well, try to divide by a, but in this case, a is 5. So I would need to divide everything on the left and everything on the right by 5. Is this going to work out okay? Are we going to end up with whole numbers? Yeah. 5 divided by 5 is 1, so we would get 1x squared. Negative 20 divided by 5 is negative 4, so we get minus 4x. And negative 60 divided by 5 is negative 12. Then on the right-hand side, 0 divided by 5 is still just 0, so we don't have to worry about changing anything on the right. This is beautiful. We took this big complex problem with these large coefficients and large numbers, and we turned it into a simple standard form quadratic that we know how to factor very easily. We've been working on this for over a week now. So draw your generic rectangle, put your x squared in the top left, put your negative 12 in the bottom right, and factor just like usual. Come up with your list of numbers. Make sure you take note of your signs. Since these signs are different, we're going to need a difference that equals negative 4x. So we're going to use the numbers 6 and 2, and then we have to come up with our signs. So all of these steps should be relatively familiar. And I know I'm going through this kind of quickly, but we've done this a lot over the last week, and I have a feeling you guys are catching on to these problems and can do them pretty quickly yourself. So when I factor everything out, I end up with x minus 6 times x plus 2, and that's equal to 0. From here, we can split this into two smaller equations and solve each one of them for x, and we end up with two roots. We end up with x equals 6 and x equals negative 2. So take a look at example 4 now. In example 4, we have a bit of a hurdle we have to leap before we ever get started. And our hurdle is, this is not in standard form. So let's first put it into standard form equals 0. To do so, we're going to undo the right-hand side. We just want 0 on the right, so I'm going to subtract 9 from both sides. So we'll have 2x squared plus 3x minus 9 equals 0. Now it's time to start thinking about factoring. But we have this 2 in the front of our x squared, so we're going to have to first try to divide everything by 2. And then after that, we factor. So, can we divide everything by 2 without getting decimal numbers or fractions? Unfortunately, no. If we tried to divide everything by 2, the first number would be fine. 2 divided by 2, that gives us a whole number. But 3 divided by 2, that's a decimal. And 9 divided by 2, that's a decimal. So our little trick isn't working. We can't do it. So we're stuck just with factoring. So we're going to have to set up our generic rectangle and factor this just like any other problem, with the exception that having a 2x squared in the top left box is going to complicate things a little bit. So put your 2x squared in the top left, your negative 9 in the bottom right. And now it's time to start thinking about our factors. I need two things that multiply together to give me 2x squared. Two things that multiply together to give me 2x squared. 2x times what? 1. 2x times 1x. Right, exactly right. So I'm just going to write that as 2x times x. Great start. So keep in mind that this 2x is going to affect what happens in this top right box. So as we're making our list of numbers that multiply together to give us 9, keep in mind that whatever number we put here is going to become doubled, basically, into that box. So it's a little harder to predict what's about to happen here. So what we're going to do is just try the various options. As you get better at this, you'll get faster and you might not need to guess and check. You can kind of just sort of zero in on the correct answer by thinking about it without writing it down, but I'm actually going to write this through. So I'm going to write down my first guess. This might be right, it might be wrong. Let's find out. How about we try the 1 and the 9? If we do that, we get a 2x and a 9x. Can the difference between 9x and 2x ever be equal to 3x? No, we'll either have 7x or negative 7x as the difference there. So this isn't working. So now notice that the 1 we put here turned into a 2x when we multiplied it by this 2x. So what's important to notice is that even though this didn't work out, we're not done trying the 1 and the 9 yet. We have to actually switch them and see what happens in the other order, because now we'll be multiplying the 9 times the 2x, and that will significantly change things. When we do that, we'll end up with an 18x and a 1x. Unfortunately, the difference between these two things is still not 3. The difference is 17. So this isn't going to work. But you have to try both. We tried 9 and 1, and we also tried 1 and 9. You have to do it both ways. But if neither of them works, then you can move on to your next option. Our next option is 3 times 3. Now, one of these has to be negative, and it matters which one. It absolutely matters which one we make negative. So watch what happens here. We end up with a 6x in the top right, and we end up with a 3x in the bottom left. For these two things to add together to give me a positive 3x, we would need a positive 6, which means that this 3 on the top has to be our positive 3. Now we need to have a negative 3x in the bottom left, which makes the 3 on the bottom negative. So now we want to write this in factored form. X plus 3 times 2x minus 3, and that equals 0. And we can now take our two factors and split them up into separate equations to find our roots. X plus 3 equals 0. 2x minus 3 equals 0. We solve each of these, and we end up with x equals negative 3 and x equals 3/2. So those are our two answers, our two roots. For this next example, we need to get it into standard form equals 0. Now, we have two choices. We can either undo the right-hand side. If we do that, on the left-hand side, we would have a negative 10x squared in the front. Now, that is not ideal. If you've tried to solve this problem with a negative 10x squared in the front, you might recognize how extremely difficult it is to manage your factoring when you have a negative here, because that means that one of these two places has to be negative, and that throws everything off, and it's just extra steps that we might not want to have to worry about. So instead of undoing the right-hand side, I'm going to undo the left-hand side. So we'll add 10x squared to both sides. And we will also subtract 36x from both sides. So once I rewrite this, everything on the left should cancel because I undid all my terms on the left. And my right-hand side, make sure to write these in the correct order. So we're going to put our positive 10x squared in the front, followed by our negative 36x, followed by our positive 18. Now that it's finally in standard form equals 0, now I can worry about my first step, which is try to divide both sides by a. Now, a in this case is 10. So if I were to divide everything on both sides by 10, unfortunately, we would end up with decimal numbers or fractions. Well, we don't want to do this then. So at this point, we could begin to factor. There is a little bit of a trick, though, that someone in class picked up on today. I was very impressed by this. These numbers are pretty big, 10 and 36 and 18, and we'd have a lot of options. If we were trying to factor 10 and 36 and 18, we could do 10x and 1x, or we could do 2x and 5x, plus down on the bottom right, we could have 1 times 18, 2 times 9, 3 times 6. This is just a lot of different options to have to go through step by step. So there's one thing we can do before we start factoring that might save us some time. Even though we can't divide all of these pieces by 10, we can divide them by something. The numbers 10 and 36 and 18 are all divisible by 2. So we can divide both sides by 2. And that's going to simplify our problem a little bit. So it turns into 5x squared minus 18x plus 9. It's still a tough factoring problem, but it's a little easier than it would have been a minute ago. So now let's start to factor. In the top left, we need a positive 5x squared. And in the bottom right, we need a positive 9. For the 5x squared in the top left, the only options we have are 5x times x. So we can go ahead and fill those parts of our factor in. Then to get a positive 9 in the bottom right, we either need 1 times 9 or 3 times 3. And we have to have either 2 positives or 2 negatives, one of the other. So we could try a few different options, like you can try 1 and 9, giving you 45x and 1x. The sum of 45x and 1x is 46x, so that's obviously not going to work for us because we need a sum of 18. So try switching your 9 and your 1. So do 1 here and 9 here. You end up with 5x and 9x. The sum of these two numbers is 14, so we're still not quite there because we need an 18. So 1 and 9 didn't work, but also 9 and 1 didn't work. So we tried this both ways. Now it's time to move on and try the 3. So we'll try a 3 and a 3, which would give us a 15x and a 3x. The sum of 15 and 3 is 18, so we're on the right track. Now we just need to ensure that we get a negative 18x when we add these together. And we already knew from the beginning that both of our numbers had to be positive or both of our numbers had to be negative. So hopefully we can see now, in order to get a negative 18x, that we want the negatives. So let's rewrite this in factored form. We'll have x minus 3 times 5x minus 3 equals 0. And then we solve both of these factors for our root. When you do that, you get x equals 3 and x equals 3 over 5. Positive 3 over 5. Note that. One more example to do. Example number 6. In example number 6, we have a similar issue where this is not in standard form equals 0. So we either need to undo the right-hand side or we need to undo the left-hand side. So let's choose wisely. If we undo the right-hand side, we'll be moving the 15x over to the other side, to the left, but then we would still have this negative 3x squared in the front. We do not like to factor with a leading negative. So instead, let's choose to undo in the other direction. So we'll undo the left-hand side. Add 3x squared to both sides. Also, subtract 18 from both sides. When we rewrite this, the left side will now be 0, and the right side, let's write our terms in order. 3x squared plus 15x minus 18. Now we're ready to divide both sides. So try to divide by a. A in this case is 3. So we're going to try to divide everything on both sides by 3. And this one actually does end up simplifying, and it gives us all whole numbers. So 3 divided by 3 is 1, so we get 1x squared. 15 divided by 3 is 5, so we get 5x. And then 18 divided by 3 is 6, so we get minus 6. Time to factor. This one will be a little easier for us because we just have an x squared in the top left. So our factors will each start with x. And now figure out a list of numbers that multiply together to give us negative 6. That means we need a plus and a minus. We also know that since they are different signs, we need a difference of our two numbers to give us the plus 5x. So the sum of 2 plus 3 is 5, but we don't want a sum. We need a difference. The difference of 1 and 6 is 5. So we'll use 6, 1. The bigger one will be positive because we need a positive 5x in the middle. And that will give us 6x and negative 1x. When we turn this into factored form, we get x plus 6 times x minus 1 equals 0. And you can pretty quickly find your roots here, either by solving or using our pattern that we know, where we just have to change the sign in the factor.